Hi, this is Sharan, and this is my video record of my mini project in which I have created a game using microcontroller. The software I've used is my MPLab IDE, and the hardware which I am using is PIC microcontroller dsPIC33ck 256MP506. So this is my code, which is in C program. So basically I have implemented a timer and an interrupt for the timer, and this is a simple game in which you have to press the button at the right moment. So the timer keeps on counting and refreshes its status, and when the right LED blinks, you have to press the button. So let me upload my code. If you press this button, your code will be run. Your code will start running, and it will get uploaded to the microprocessor. This is a snap debugger, which is used to debug the microcontroller in case you get any problems. And this is the main setup. I have 5 LEDs, 2 different kind of switches, and 7 resistors, and 7 LEDs, not 5 LEDs. This one is just to connect those positive and negative on that side to this side, so that the whole system looks clean. So as you can see, this LED constantly shifts. The blinking of these serial LEDs constantly shifts at a particular time interval. And the objective of this game is to press this button, the button which I am pointing to, when the yellow LED blinks. So yeah, I pressed it correctly and the green light blinks. That means I won the game. If I press the button when any other LED is blinking, I have lost the game. And if I lost the game, the red LED blinks. Let me show you. I pressed it at the wrong time, so the red LED blinked, and the system resets again. Now I can play this level at 2 difficulties. This button is for 2 difficulties. Let me increase the difficulty. Right now I've increased the difficulty, so the shifting of the LEDs is at a larger pace, is at a higher pace. Yeah, I won the game. If I press it at any other time, I've lost the game. So let me explain the code also. Let me explain it briefly. For different pin configurations, this is the main function, and these are the pin configuration for the main function, and this is the timer interrupt service routine, which is necessary for this program. And this reset LED is a function which we will be using. Now the first we need to mention which are all the output pins and which are all the input pins. In order to blink the LEDs, that is an output, and in order to get the readings from the button and from the main LED, those are all inputs. So we have defined those, and then these are the configurations for the timer. First we clear all the registers in the timer, and then we set our prescaler at the timer to 1:256. If you have an higher ratio of prescaler, your timer would go much more faster. And also I have used the internal FRC clock and enabled it. And this is the period register. So whenever your timer counts, increments itself, and whenever it reaches this value, that is 2F00, 0x2F00, and that's an hexadecimal value. Whenever it reaches that value, the timer resets itself, and it again starts from 0, and it again starts counting from 0. So, and also since whenever the timer reaches the match value, I need to shift the LED. So I need to use an interrupt. So I am enabled the global interrupt and the timer interrupt. And when I've set this particular register to 1, this particular bit of the timer 1 register, control register. So if I've set this bit, the register can shall start to count. And I've set the initial output of the red LED and the green LED to 0. And here the while loop starts. Just like in Arduino there is the setup and loop, the while loop is like the loop. And if the level button, that's the this button, if I press this button to left side, I will have a different ink value. If I press this to right side, I will have another ink value. So ink value is the incremental value. So for different ink values, you will have different incrementer of the count, and that will give you different speeds of shifting of the LEDs. And then this is the gameplay. This section is the main section. Whenever the button is pressed and the yellow LED is blinking, that is this. If the button is pressed and the yellow LED is blinking, your green LED should be enabled. That means you have won the game, and your system should go back to reset. This reset LED is to turn off all the LEDs at that time. The count is the main variable which enables which LED should blink. So the count is initially 0, and then when the count is 2, the first LED blinks. When the count is 4, the second LED blinks. And when the count reaches the 5th LED, the count again goes back to 0. In the meanwhile, this interrupt service routine gets called only only because of the internal timer. So the timer only decides when the count should be incremented, and so it's the most important part. And the red LED should be blinking whenever you press the button and the main LED is not blinking. So when the main LED is not blinking and you press the button, right now the main LED is not blinking. Right now the main LED is not blinking and I'm pressing the button. So the red LED blinks and it indicates that I've lost the match. So this is my basic game.